Hello everyone, welcome back to the Avalon game project. So last time we have done the easy part of the refactoring. We have sorted out all the changes we want to make to constants and entities. Now I think we want to handle the harder part. Let's revisit the states. And so the reason, so before we revisit this, before revisiting the states, I think I'll just have a sample example of how this state machine is going to work. So I think I think this is what we're gonna do. So I'm not gonna write tests for this state machine. We're just going to lay down the ground foundation of how these states are going to work, how the state machine is going to get the current state and handle each other, handle the transition of each states. Okay, so the so what's so the state, so remember, remind everyone that we are going to deploy this to lambda, to AWS lambda. So the state machine object will be created each time the backend is called. Like for example, let's say it's a 10-person game. Once the game is created, 10 players will be sending requests to join game. In this case, a state machine will be called 10 times, and each time it has to reconstruct where, at what state the current game is, and then handle the current event as needed. So that's why we'll have to get the game using game ID. Let's do it here. So we'll have a game ID here, which is string. Let's pass the game ID to repository once we get the game. Here, so I think first of all, in the state machine, we will have a we'll have a constant of actually we'll have a constant of state name map. State name, and we'll need all these. Round the vote, quest the voting, what was was it? Endgame. All these. Actually, this is dot alley. Yes. 1, 2, 3, 4. Okay. So now, when we set up the state, actually, we'll have to set up all the states. So game setup state equals to game setup state. Oh, we'll need all the services. Or maybe we could create the services here. I think we'll create all the services here. We have which service? We have the com service, we have the repository, so we have the game service. We have the player service. So the game service requires player service. We'll have to have player service first. Player service is repository. Then game service, it's the same thing. Okay, I'm gonna let's keep the same exact order. So com repository depending service. Oh, by the way, I want to make sure that everything is passing. Okay. So it's com communication repository and player service. So now after the player service, it's the round service. Okay. Com service repository. Request the service. Run the service. Factoring, change signature. Okay. Okay, we have all these, very good. So once we have these, the game setup is team selection, game service, player service. So before this, we need the team selection state. No, actually, we should start from the very end, which is the end game state. It requests game service. So end game state, what? So that's the quest voting state equals to quest voting state is the team selection end game quest service. So first we have to create team selection state voting round voting. So round voting state equals to team selection state. Wait, is this a double dependency? Oh shoot. This is a circle dependency. I thought I got rid of it. So team selection, round voting, team selection. Oh, that's bad. So how can we get it? So not good. We should not have a circle dependency. So what we can do is to pass in the states after its creation. So in that case, we could create all the states, then pass in the dependent states to bypass to deal with the circle dependency. Yeah, let's do that. Then this requires some kind of refactoring. You know what? I won't do that. So I'll just do this. So endgame, quest voting. Let's actually start from the beginning. Game setup, team selection, round voting, quest voting, blah blah, right? So once we have these states, we can just once we have these states, we can even do this. So we create the service. Do we need the selves? Yeah, let's just keep it here, it's fine. Equals to state name map game.state, not state. So game entity, we have a, oh, we don't even have a state. let's add it. Yeah, this. Okay, let's see how many things fail. Okay, we're not creating game itself. That's good. Yeah, not bad. Okay. Okay. State equals to game state. Wait, why? Unresolved game. Why? Game is right here, literally. Okay, doesn't matter. So once we have the current state, okay. Okay, just in case. Okay, so now we have the passing the game ID. Yeah, so this is how we're going to do this. We set up all the states, then we pass the event to the current state, and then if we are going to the next state, we are going to call the onExit of the current state, and we are going to call the onEnter of the next state. And if the next state is a transient state, which means onEnter returns something, then the current state will be that. Or actually, we can just delete this entirely. Okay. So this is how we're going to call everything. So let's just remember this. Okay, once we have that, okay. Once we have this, let's go back to the game setup state. So the game setup state, so on handle player joined. So again, we really wanted to have the do we want to have the announcement in the state, or do we want to have it in the service? I was thinking to have it in the state because when the state transitions, so the communication almost always comes with an event. So whenever we receive an event, we choose we choose what to do, the action according to the event we get. So in that case, I wonder if we could make all these handle method just to return an event so that we could we could broadcast it here, or a state is just a state. It doesn't care about what to announce. Let me think. We could give it a try potentially. So here, let's for example, when the player joined, we save the player. We create a player. We create an event and we broadcast it. Wait, here I have docstring already. Why? Let's say save player. What do we have here? We have the payload. We have the player name. We have game has secret. We create a player, and the player itself is to be broadcasted the name and the ID. We'll be sending this to put event. Oh right, we decided we want to create an event service so that we don't have to create all these events anymore. So everything would depend on event service, which is good, I guess. Okay, I think I'll do that. Event service should be simple enough. Or here we could just once we have that, maybe we could do game ID. I want a player ID. Game ID. We want a player name. Secret. What else? Oh no, the event, we don't need a secret. This is good enough. So we're gonna return an event. So in this case, we could just return, we could just create an event. First we want to create a payload. Player ID, player name. Then so here we want to get every recipient put event. What else do we need? We need a timestamp. Okay, I see. So wait, should I get a timestamp now? Do we have a timestamp here? Yeah, this. Not this. The there's an easier way. I think time.time would be nice. Did good enough, I think. Just time. Do we have to I would rather a more human readable. Do we have to? Interesting. We could use a string value maybe. So the event, the timestamp has to. Oh no! I don't want to do it. Ah. Oh, I know. Okay, we will deal with this. I'll add one. This would be the last to do. Change the type to string. Okay. Once we have that, then all we have to do is just do this. Okay. So I think we got this one. Then the player service would have a dependency on event service. No, everybody's gonna have a dependency on event service. So, okay. Okay, we have to add a type. Okay, so once we have this type, player service is failing. But the good thing is, all we need to do is to have another fixture. So now everything should be passing this. Okay, so let's come back, game setup, handle player, then so instead of this, we will have something like not even timestamp. We don't care about that anymore. The event would be player join event, player.id, the event type. We could create event. Game ID. Game ID is a string. Event type is event type. We have recipients is a list of string, then a payload, which is a dict of str and anything. The return value is an event. And the return value is repository put everything these. So these are going to just return recipients. Yeah. Yeah, fine. Okay, this looks pretty good. So we don't even need the event type. Frankly speaking, we don't really need the recipients. Actually, this I don't even want a recipients, because this we know for a fact is a public is a public event, so it's just like that. Okay, so once we got rid of this, the rest is, yeah, so we don't even need this and this this method anymore. We could just go back and just do this. Okay, let's see. Player ID, event, game ID, and the player name. Yep, looks good. Actually, we could add a schema here in the entities or in the events. Instance events, event type. We have player join the event, and with player join the event, we could have a schema, right? Okay. Yeah. Sorry, everyone. I know I'm all over the place, but the thing is, here when we're doing a refactoring, I'm trying to do lots of things at the same time. So, as I mentioned before, I promised to get a library for validating the event itself. So I'll do this. I will wrap up today, and once I finish recording, I'll go do some investigation on the validation package we can use and try it out. Once we try it out, we could just use it here to basically, all we need to do is basically just compare event.payload to a schema. Yep, event.payload to a schema. And frankly speaking, I'm even thinking, should we be, this is more fundamental. So in the state machine, we assume that the incoming event, no, we'll have to do that. There's no no way around it. Though there are some so actually there are actions and events. Now think about it. All the things we get are player actions. Like for example, when even the player joined is an action of player who just joined this particular game. Game started is an action from the admin. So when we cast a vote, it's always an action. So I'm actually wondering, so event, we could use this as internal. And if, say for example, if we were to have an action, action. So let's say it's a data class, class action. We don't, action doesn't have to have an ID. We'll have because we're not saving this, so it is entirely, it's fine. Or we could no, this doesn't need to have an ID because we're going to save it. Yeah, because action is what we get from the okay. So action should have a name. It should be it's not string. I think it's more like a action name, just like type, action type or name type. Just like event, we could have an enum of as action type, which is a enum. Then what we have here is action type is start game, join game, select team. For example, I'm gonna deal with that later. So type, it can be an action type. What else? We of course have a payload. It's a string of, it could be anything. Yeah, but ideally I want a string to string. Yeah, it should be like that. A player ID, of course. So actually, yeah. So it's a game ID, string, a player ID, what type of action and what payload do we have. Is that everything? Yeah, I think adding this would make things much clearer. Okay. Okay. I will think about this. Let's take a pause today. I think we're all over the place. I should take pause and sleep on it. Well, I know we didn't made much progress today, but polishing our code is actually one very important part of a project. I should have thought all about this beforehand, but it's never too late to refactor your code. So yeah, let's just see what we can do to improve this code. Well, yeah, thanks for watching. Thank you everyone. See you next time. Bye.